today's lab, your group will be assigned a time. Now note that in the iodine clock reaction, on Tuesday you measured the rate at room temperature and figured out the rate law. And what you did to do that is you varied the concentration of the IO3 minus, that's solution A. You added that solution to solution B, the HSO3 minus. Then it took a certain amount of time for the solution to turn blue. So your group is going to be assigned a time, for example, 30 seconds or a minute and a half. You and your group want to identify or calculate or both the concentration and temperature to make this reaction turn blue in your assigned amount of time. And then, this is the best part, your group will go in front of the class and mix those reactants and see how close your time gets to the assigned time. You don't get to practice this based on your calculation only. So for this part of the lab, would you like your grade for this lab to be based on this part only? Because it makes it really easy. You don't have to write a report. No discussion, no conclusion. Because really, if you show, let's say that you were assigned 90 seconds and then your group got it, say, in 88 seconds, that means, boy, you're certainly, you know what you're doing and you deserve a good grade. You know?
When we get it close to our assigned time, we leave it at that, and if not, then we have the opposite, right? So
you gotta figure that out before. Yeah, you want to determine that before you put it stuff. Yeah, so this is what you guys as scientists and engineers and health professionals do. You know, based on a theory or a principle or a law, you make some prediction and then you test to see if your prediction works. So that's what you're doing in this part of the experiment. So anyway, maybe during lab, your lab section can figure out whether you want to base your lab grade solely on how close you get to. So that's the thing, because what we'll do too is we'll figure out if you're within a certain percentage of your assigned time. So for example, if you're within, we could say arbitrarily 10%. If you're within 10% of your assigned time, you get an A. Within 20%, you get a B. 30%, C. Greater than 30%. Oh well, that's the breaks.
So you have to choose before or after if you want to do the experiment?
No. Juan asked the same question. You have to just choose before.
good.
Yeah.
Like every group or like
The whole class. The whole class.
If you're sick, if you're sick.
Yeah, the whole class has to say.
I said dead arm.
So, and this is also a case of, for example, if one group wants to do this for their final grade, and if everyone else wants to do a report, that means that one group has a lot of persuading, encouraging, convincing for the rest of the class. And that's actually part of what you guys do when you're scientists and engineers. You give your writing report, try to convince people to give you money. It's sort of the same thing. You got to convince people to. Well, I won't say it's like being a politician, but it's sort of the same thing. You're politicking to get your ideas. Bruce.
Has anyone ever done that?
Done what?
Without...
Oh yeah.
Really?
Yeah, because I've got the data on my computer. I tabulate the data every semester and you see how close they get. So some groups get within a second or two. It's very, very impressive because the tension really builds as it goes to feel like 90 seconds. 80, 81, 82. Everything gets sort of worried. and all of a sudden turns blue, and then everybody's just relieved and happy at the same time. But when then it goes 90, 91, 95, 100. Oh no, what's happening? Then they get really discouraged too. So it's you get this roller coaster of emotion just by seeing what happens. So for me, I try to detach myself from any emotion from the event because I've seen it all before, and for you, it's whether you want to average.
What's the average?
Jeff, whatever you want to do. That's up to you. That's up to your group. Pardon?
Do you have data for unstir the time you should take? Washington. Never mind.
Yeah, that's up to you and your group whether you want to stir it or unstir it. Leave it unstirred. Okay, so anyway, we'll decide that in lab today whether you want to do it all for the grade or do what we've been doing in the past. Okay, so we said that a rate law helps us figure out tell us about the reaction order, and it tells us, we said that the rate law tells us that if we double the concentration, that's going to change the rate. Okay, whether it's first order in that reactant or second order, whatever. The rate law also tells us about the reaction mechanism. Now, the reaction mechanism is the sequence of elemental steps, and an elemental step shows us which bond breaks and which bond forms, and the order in which bonds break and bonds form. So it turns out that if you add up all those elemental steps, that gives us the overall reaction. So here's a reaction mechanism for me getting to work. So from home I walked my car. That I rounded it to 1 minute. That doesn't take me that long. Use the whole time. Then from the car I drive to the parking lot. That takes me 16 minutes on some days. Get to my parking lot to my office. That takes 2 minutes, depending on how fast I'm walking. And then from the office to Merrill 22 takes me a minute. So note that there's 4 steps in this mechanism. If we add up all 4 steps, what would be the overall reaction? Okay, so you add equations 1, 2, 3, and 4. Okay, so if we do that, okay, so let me write it this way, just to make it more general. So in step 1, we have A going to B. In step 2, we have B going to C. In step 3, we have C going to D. And then in step 4, we have D going to E. So we add all these up, what do we get? Yeah, so note that, B cancels out, and C cancels out, and D cancels out. So yeah, we get A going to E. This is our overall reaction. So the sum of these elemental steps in a reaction mechanism must equal the overall reaction. So that's what we're doing here. So if we do this, home to car, car to parking lot to office, office to Merrill 12, we get home to Merrill 12 as our overall reaction. Okay. Now, which step of those 4 is the slowest step? Okay, so there's 4 steps in this reaction mechanism. Which one was the slowest step? So is step 1 the slowest step? Is step 2 the slowest step? Is step 3 the slowest step? How about step 4? Now, yes, you're right. So note that this one takes the longest amount of time, so this is the slowest step. So in the rate law, the order of the reaction with respect to each reactant tells us about the slowest or rate determining step in that reaction. Okay, so again, the rate law refers to the rate determining step. Now, it's not easy to figure out a reaction mechanism, but is very important to understand a reaction mechanism because that tells us how a reaction or a process works. So, a lot of research by researchers at universities or researchers in drug companies or pharmaceutical companies want to figure out the mechanism how a drug works. And that helps them in designing better and more effective drugs. Okay, so that's one example of reaction mechanisms. Okay. So the same thing is true with, for example, the catalytic converter in your car. So the catalytic converter in your car is platinum. So how can we get that reaction to convert those unburned hydrocarbons as they pass through the catalytic converter to be converted into CO2? Okay, so like I said, there's a lot of research in that. Understanding how reactions work, that is the mechanism of the reaction, because then we can design better products and better reactions, get things to work better. Okay, so like I said, the order of the reaction tells us the number of reactant particles and the rate determining step. So let's do this as an example. So here's the reaction. 2NO plus Cl2 gives 2NOCl. This is from the textbook. This is problem 14.47. NO is actually considered a pollutant if it's part of the exhaust from a car engine. But NO is also a very, very useful chemical in our body. Does anyone know what NO is used for in our body? Is nitric oxide. And nitrous oxide is N2O. That's that's laughing gas, which you may have had at the dentist's office. Yeah, NO is what's produced by one of the most popular drugs, the most best-selling drugs in the world. It's actually not an over-the-counter, it's a prescription drug. It starts with a V, but it's not Vicodin.
Viagra.
Yeah, it's actually Viagra, because note that NO relaxes certain types of